Assalamualaikum warahmatullahi ta'ala wabarakatuh. I am Ali Eslopong. Now, I'm going to discuss the dynamic equilibrium. Dynamic equilibrium is a situation where we have an object that is moving in a straight line at constant speed. So, first example, let's assume that this is an elevator. So, this elevator is moving up uh, thanks to the tension in the cable T or the tension. So, and of course, because it has a mass, there is a weight force, this mg, and let's assume it is moving upward at constant speed, so v constant. So now this is a dynamic equilibrium problem. We write therefore the net force must be 0, so F net is equals to 0. So we need to take this equation and write it along x and y and along y, bearing in mind that of course that along x there is no force, therefore F net x is equals to 0. So but F net y is a bit more interesting because F net y has two terms in it. So up is positive, so let's write it F net y is equal to the tension minus the mg is equals to 0. So, and this we come to the conclusion that T is equals to mg. So example 2. So this is the free body diagram, a box. So I put a coordinate system. So we had placed a box with a mass, therefore weight mg on the floor. This which means if there's mg, there's a normal force. So we're pulling, imagine that we are pulling the box, so theta. Now let's assume that we are pulling hard enough the box that the box is actually moving at constant speed to the right. So this, and let's assume that there's a friction now. It has to be a kinetic friction because the box is moving. So we have the friction, the kinetic friction, F equals to, okay. At any rate, if it is moving at constant speed to the right, we can still write F net equals 0. So let's write and F net equals 0 is a vector equation. Now along x we have two terms, the tension and the friction. Since to the right is positive, this component of tension right here, which is a t cosine theta, is going to be counted positive, minus friction, which is truly horizontal, just pointing in the negative direction. So tension cosine theta minus friction is equals to 0. So in y direction, F net y has three terms. The normal force and up is positive, mg will therefore be counted as negative, and the component of tension is going to be counted as positive. So we have F net y equals n plus t sin theta minus mg is equals 0. So In example number 1 and number 2, we got similar equation, though it is not exactly the same because in example 2 we have kinetic friction, but the point was to show that this box moves at constant speed to the right, therefore F net is still 0. That's all, thank you.